The current topic is SLSA is not a budgeted software supply chain security in overview. SLSA is a framework which orients bits what you can do about supply chain threats and helps you organize your own supply chain to remedy a bit of vulnerabilities that can happen. So, from the agenda, we're looking into vulnerabilities. What are vulnerabilities? Where can you expect them? Then how can they enter your supply chain if they're everywhere there to begin with? And some best practices to remedy them. First off, vulnerabilities. Just a basic example, you have a gate, you have a door, something like that. And there are certain vulnerabilities that can always happen, like you leave the key in the door, which is probably not a good idea, or you leave it entirely unlocked. Example would be in software engineering that you have your database keyword in the travel board, which can be found by Google, which is not great. Cheeto chip for a lock, where steel bolt would be better, is also not great. You can say, yeah, we have basic auth, but that might not be great because it can be brute force. Or you just have a really secure gate in place and you can just walk around it because there's another dependency. So dependency is your neighbor in this place and he doesn't have a gate, so yeah, it's pretty useless. So you need to be aware that in recent history, Log4j was a vulnerability that everybody remembers. It was a zero-day vulnerability, which means it has always been there, or it has been there for a long time. If you think about a castle, it might be a secret underground tunnel that somebody somewhere built there. You don't know about them, but they are always there. Right on to supply chain threats. Now that we know that there are vulnerabilities, we want to avoid that they are entered in our supply chain. It can be easy things like you just make one update in your software. Like this is just the tiny number, the patch version of your software that you have. And if you look at the image, there is another tower there. And it has a window and a ladder, which might not be what you want from a software update. So this could be a malicious update that they didn't write it in changelog, but it is there. Could be that you build your castle and you need a PDF exporter, which you couldn't be bothered to write yourself, because why would you? And then you just update it and suddenly there is another tower and an entry to your software like an SSH tunnel or something, which is not what you want. So going about SLSA, it addresses some of these issues on the supply chain. If we look in this place with the producer, this would be your average developer, your coder. He has a laptop, he writes code, and then he uploads to Git, which would be a source, and you have some kind of runner or your build pipeline, and then it's packaged and stored in an artifactory, or in the Docker case, a registry, and you have dependencies which are integrated in your build process, and then the consumer would be either an entire other customer or open source repo, or just your software which actually runs on your server. Which also means if the consumer is something like an NPM repository, then everybody might have it already, because NPM works that way. So what can happen at this stage? From the coder to your Git repo, so source might be your main branch in this case. And one of the ways to stop or mitigate some of these issues is to just have peer review, so unauthorized changes are caught by another person. There are several other issues that can happen here, like the dependencies were hijacked and some other dependency was injected here, which you don't want. Or the artifact package entirely here is replaced, and then you go to the server and it's something entirely different that was deployed, which, yeah, you might not want that. These are all issues that have happened, that have been exploited. If you go to the SLSA framework website, they have examples of these issues, how they can happen, and yeah. So we don't want that. They are aware of that. They want to work around that. One of the first steps to go against it is, what do I actually have in my software? So common concept for building is the bill of material. For a bicycle, that would be, you have a bicycle, you have a wheel on there, you have a handlebar, and your frame contains several other parts. If we look into NPM, it would be you download a package, and these packages have other packages. And the bill of material, in this case the software bill of material, would list your dependencies that you have in your software. Then you have the versions for them, and yeah. For a bicycle, that might be simple, doesn't contain much parts. If we look at the car or a more complex project, it gets pretty complex pretty fast. And yeah, I don't think anybody or a lot of people can know which parts are involved in a car. So one of the things we can do about it, we can scan for vulnerabilities and in the software bill of materials. So we have the versions of all dependencies that are involved. We have vulnerability databases. We tell it, hey, I have a PDF builder with the version 1.2.3. Are there vulnerabilities in there? And it tells us, yeah, there's an SSH client integrated in it. And if you want to fix it, you need to set up a version, or you should use it. Some of the examples are the NIST CVE databases or GitHub advisory database. These have usually IDs that you can look up, and it will tell you what the vulnerability is and how you can mitigate it. So I talked about NPM, and as always, yeah, you can't really overlook an NPM tree of dependencies that's involved in your software. It's just too much. Another way to look at it, if you go back to the castle, you have like a Spring Boot, your log4j. I know they are swapped around. The log should be log4j, but it doesn't make sense in my example because somebody could just interject the bricks with styrofoam, and at that point, yeah, your castle might be made out of styrofoam and has several weaknesses that you don't want in your software. All right. What can we do about all these issues? One of the first ways, we can just scan for them. We have the bill of material, we can generate a bill of material, and then we can say, okay, we look for vulnerabilities in them. There are tools like Privy for container scanning and software binary scanning in your packages. Right, does this as well. In your code themselves, there are static application security testing, are they called. These are code scanners. If you write something in your code that's not really secure, it will tell you, and then you can work against that. And also, if you scan once, it doesn't mean your software is secure if it doesn't have critical findings. It might just mean that you scanned once and in 2 weeks there is a new vulnerability finding that was found. So scan regularly. Just because you have scanned once doesn't mean your prod deployment is secure. Another way, you can use Renovate or Dependabot to use in your pipeline to keep your dependencies up to date. So old dependencies are more likely to have found some vulnerabilities, so if you stay up to date, there are probably less vulnerabilities found at the moment. Doesn't mean there aren't any, just not found yet, so more secure. We have for Axo platform repo already. You can just inject it into your project. You just need to invite a Renovate member, and then it scans for you. There's a tutorial, a README, where you can look that up. That's really easy, and I suggest you use it. If you use it privately on your GitHub repositories or something, I think Dependabot is more available there, or just, yeah, more people use it there. But anyway, just use some kind of dependency management tool, and then you're good. This is what it would look like if you have critical findings in your pipeline. What this means is, yeah, there is something. It doesn't mean it's it affects you, but you need to look into it. And if it's something like Log4j, okay, Log4j is bad because it was a zero-day vulnerability, but it might be something that's newly injected, then you want to look into it and make sure that it doesn't deploy with your software. So you stop the pipeline there and say, okay, I look into it and I'll take care of it. Which brings me to the next point. You need to look into the single vulnerabilities that can be found. First question is, are there fixes available? So this would be the scan report here. We have here like the gen mapping, it's called, and it doesn't have a fixed version, but it's a critical finding, so that's pretty bad. So we need to look into like this ID, that's the GitHub advisory database. We can look it up, and usually often it says, yeah, it's only a vulnerability for a certain configuration. You need to keep in mind sometimes the developers of these tools also don't say, they don't think that's a critical finding. So they will just straight up say, no, we don't fix it. So then you have a critical finding that can't really be removed if you really need a dependency, but you need to ignore it because the developers said, no, that's not a critical finding. So yeah, the different vulnerability databases are also not consistent. So the GitHub advisory database might say something different from the CVE database. Yeah, just be aware, you need to look into it. I often had like a Postgres client or something that told me, yeah, we have a vulnerability, but it's only for a certain configuration where you need to do something, and the default configuration is not an issue, but it's still a critical find because it might happen. But still, you need to grab the ID, put it in your ignore file, and then go on with your life. So yeah, just be aware that there are several issues with these findings. You need to be aware of them and how to deal with them. So another way to help you, in the slide before, there might be fixed versions, so you can just update. And the easiest way to update is to stay updated in the first place with Renovate and Dependabot. This is what would look like if Renovate run on your project. You have a bunch of merge requests created. It has like for the commons IO a new version. You can look into it. If this works strongly depends on your pipeline. So if your pipeline is bad and doesn't test everything and doesn't have smoke tests or something, it might say, yeah, it's all good. You merge it and breaks the code. So it's not good. So be aware that you need to take care of good pipeline hygiene. Also what it gives you, it has options like auto-merging versions. So if it's a private project and you really don't care about new updates and you just want to get rid of it, you can even merge major versions if you don't care about it. So if it breaks, alright, I'll deal with it later, but I want secure code. Usually in projects like the Basel where we are, we just merge patch versions because they're usually fine. If you go back to my example, you can see that it might be a bad idea because suddenly you have a window in your castle, like an SSH channel that's open or something. So we need to establish a certain kind of trust with these producers of the code. So somebody wrote Lombok, so we need to trust them somehow. What's popping up at the moment is producer signatures, or rather signatures of your artifacts and your images. One of the ways to do them is with Cosign or Sigstore. Cosign is part of Sigstore. What they do for you, they tell you, if you go back to our example of the castle, it's made out of bricks. Some of these bricks are dependencies, and these dependencies are now signed by the producer. Yeah, that's mine, that came from my factory, and it's probably fine. So it's some way to tamper-proof that somebody injected something different into the artifacts. And you can check for them. Established repositories like Docker have the Docker Content Trust for this. More open source is Sigstore and Cosign, and they can sign your Docker images and the artifacts attached to them. The bill of materials, so the software bill of material, the SBOM, is a horrible name, but the software bill of material can also be attached to your Docker images and also the vulnerability reports you just generated. So if the vulnerability report is like, can check for it's a week old, but it was created by my runner, something like that. Examples of this, the Docker content trust can be inspected with a simple command. You can also have a configuration in your Docker which only pulls images if they have Docker content trust, if you're that paranoid about your Docker images, which you should be. Or you can check for cosine. So here is a command. We need to give it some kind of identity or IDC issue. At the moment that's a wildcard, so I don't care about it. Then I need to look into it and I actually need to specify, yeah, that's from this specific GitHub repository with this specific tag, and then refine. It will tell us this below, but this is like this kind of text, so I didn't do it. It will just tell us, yeah, the cosine claims were validated. What does mean is cosine works in a way that it uses signatures, short-lived signatures to inject another signature into our image. And when we have that, we can check against it with a public key. And then we have a public record where we can say, okay, this was signed then and it's probably correct. On a big level, it's a bit more complicated. But yeah, it establishes producer trust. So, some Docker registries already support these features. We can just use our image and have it signed with cosine. Then we have our SBOM software bill of material for the image, and even for our single artifacts, we can actually sign them and put them there. So, in the context of Buffer, for example, we have like Java modules which we push to our artifactory, and then they are injected back into an image, and we can have SBOMs and vulnerabilities for both of them in the Docker image and can check for them later. And we also sign them with a private key. If we are on a public platform like GitHub, it can be done keyless. There is a key involved, but it's short-lived. In our case, because it's on-premise, we can't really use that, so we need to have our own key, which might be bad because if somebody has that key, he can just push images and tell, yeah, that's ours. So, yeah, be aware of that. Some Docker registries that always support us are AWS, GitHub, I didn't mention GitHub here, but GCP, Docker Hub, Azure, a bunch more, you can look them up. Yeah. For other repositories, there are also, at the moment, I think in beta phase, for NPM, PyPy, and Brew, for example, I found. So it's popping up. You can check with cosine for if the producer signed their software, and then we make sure, yeah, we only pull images or artifacts that were made by this producer. So now we have the signatures, and we need to make sure when we run our software that they are still there, and that there is nobody that doesn't have them. One of the tools that helps us there is Kyverno for Kubernetes. I'm not really aware of other tools that do that at the moment for other container orchestration tools. But yeah, at Buffer we use that for telling us if the vulnerability report is older than a week, and telling us if the cosine signature is valid. And if it's not, we might be able to say, okay, we are not running this here. Or we can even do more stuff like, if it's a root user that runs this container, we can tell it, you're not running here. So we always make sure that we are running non-root, because there are less possibilities of hijacking the container and doing bad stuff with it. All right. We talked about a lot about dependencies and how we update them, but the best way to avoid having vulnerabilities is to just have less dependencies. So the easiest way at the moment is to just use like an Alpine image. Alpine is, compared to Ubuntu, it has, it's more locked down, it has less dependencies, and if it has dependencies, they are more regulated, like they don't have as much stuff in them that can be exploited. Another image producer is ChainGuard. I'm a big fan of them because they really have even less stuff than Alpine, and if you want something, you can use their own proprietary, or not proprietary, open source platform to inject new packages into them and build them like Lego blocks, what you really need, and everything else is gone. It's not in your image anymore. In the example here, this is a PHP image, and if you just pull it from Docker Hub, it has 175 MB, and the ChainGuard image just has 15. So they have vulnerability findings here. So this is a big number, but usually that's like trivial or non-findings. So it's a bit overblown. The critical findings are not as much, but they can and they are still there. And also, just think about it. You just need to store and download 15 MB compared to 175. So if you have many servers, this might also affect your bill at the end of the month. And if this doesn't work for you, you can build your own images. So yeah, ChainGuard I wanted to talk about specifically because they also have, for the most popular programming languages, their own images. So if you just have a Go image or something, you can just go there, get it, use it in your Python to build your code, and then inject it in your Go runtime image. And it's there, you're fine. It's only the latest versions because they want to pay. They want you to pay them for their versioned files or images. So if you need to stay on a specific version, be aware of that. And if you really need a specific version, you can still build your image yourself. So in this example, I just wrote a simple Docker file which creates a Grafana. It's just from the Wolfie base. So talking about Wolfie is the base image of ChainGuard. It's named after this tiniest octopus in the world. You can actually Google that. It's pretty cute. And yeah, it has just the base layer of Linux that you need. And then you have their APK registry where you can get their packages. So this is like 5 lines of code. I update the registry that I need. Then I say, yeah, add Grafana. And I say, okay, don't run this in root. So this is the random number that's there. That's actually not a random number, that's the non-root user. And then, yeah, just run this command. So we have a really secure, tiny image, but trade-off, you need to store it yourself, you need to manage it, and you also need to keep it up to date. So this might not be the best use case for everybody, but it's an option to have, to just have minimal images, and we can scan for them, we can find vulnerabilities there. Yeah, that's what we actually do at the buffer. Alright, talking a bit more about SLSA. So now we are aware of the certain supply chain threats and what they can do, how we can avoid a bunch of them. They have certain levels assigned to these kind of vulnerabilities. I'm almost gone off time. Yeah, so if you do nothing, you just have your developer laptop and you straight deploy to prod, you're at level 0. So that's not great, it's a level, you're on the board. With level 1, you at least have some kind of reproducibility. So provenance is another strange word. It basically just means origin. So you said, okay, I have this laptop, I ran it here, and I said, okay, I ran it here in the files. And then you also have you might have your Git repository, which also has your code. So it's reproducible on another laptop. You also have documentation for how to build it. Yeah, that's pretty easy in most cases. Level 2 is a bit harder because now you need to prove that you actually ran it on a secure environment like a GitLab runner and attach a signed provenance. So that's what I talked about with the keyless from GitHub with cosign and or your own private keys, and just tell it, yeah, this is mine, and here's a public key where you can actually see that it's mine. Alright, And build 3 is even harder. So at the buffer we are probably between here somewhere. Build 3 is insanely hard because you actually need to make sure that your runner is completely encapsulated, can't be accessed anywhere, and yeah, it gets harder and harder, but it helps you with, yeah, the focus is tapping after the build. So if your code is uploaded in Artifactory, if somebody changed this package, we can make sure, no, it's not from me, so I shouldn't use it. And yeah, doing the build tampering is another case. This would be like tampering here, which is really hard to make secure. The other, the level 2 was making sure that at this place nobody can actually inject something there which we can't detect. So this is a really quick overview of a big topic. I hope it's understandable what I wanted to present. Yeah. If you have any questions, now would be the time.